Welcome students. In the last class I discussed about nature of physical world and measurement, and also we see learning objectives, science introduction, the scientific method, and physics introduction, and finally the branch of physics. Today we are going to see about scope and excitement of physics. Discoveries in physics are two types. One is accidental discoveries, another one is well analyzed research outcome in the laboratory based on intuitive thinking and prediction. For example, magnetism. Magnetism was accidentally observed, but the reason for this strange behavior of magnets was later analyzed theoretically. With this knowledge, artificial magnets were prepared in the laboratories. Theoretical predictions are the most important contribution of physics to the developments in technology and medicine. For example, the famous equation of Albert Einstein E is equal to mc square was a theoretical prediction in 1905 and experimentally proved in 1932 by Cockford and Walton. Physics has a huge scope as it covers a tremendous range of magnitude of various physical quantities such as length, mass, time, energy, etc. It deals with system of very large magnitude as in astronomical phenomena, as well as those with very small magnitude involving electrons and protons. Range of time scales: astronomical scale to microscopic scale 10 to the power of 18 seconds to 10 to the power of minus 22 second. Range of masses: for heavenly bodies of electron 10 to the power of 55 kg to 10 to the power of minus 31 kg. The actual mass of an electron is 9.11 into 10 to the power of minus 31 kg. Carrying out new challenging experiments to unfold the secrets of nature and in verifying or falsifying the existing theories. The most interesting part in the designing of useful device based on the physical laws. For example, use of robotics, journey to moon and to nearby planets with controls from the ground, technological advances in health, science, etc. Probing and understanding the science behind natural phenomena like the eclipse and why one feels the heat when there is a fire or what caused the wind, etc. In today's world of technological advancement, the building blocks of the engineering and technical education is physics, which is explained with the help of mathematical tools. Physics in relation to technology and society. Basic laws of electricity and magnetism led to the discovery of wireless communication technology. The launching of satellite into space has revolutionized the concept of communication. Microelectronics, lasers, computers, superconductivity, and nuclear energy have comprehensively changed the thinking of and living style of human beings. Physics in relation to the technology and society. Physics and technology can both together impact our society directly or indirectly. For example, 1. Basic laws of electricity and magnetism led to the discovery of wireless communication technology, which has shrunk the world with the effective communication over large distance. 2. The launching of satellite into space has revolutionized the concept of communication. And then 3. Microelectronics, lasers, computers, superconductivity, and nuclear energy have comprehensively changed the thinking and living style of human beings. Physics in relation to chemistry. In physics, we study the structure of atom, radioactivity, X-ray diffraction, etc. Interdisciplinary branches like physical chemistry and quantum chemistry play important roles here. Physics in relation to biology. Biological studies are impossible without a microscopic design using physics principles. Invention of the electron microscope has made it possible to see even the structure of a cell. X-rays are used to diagnostic purpose. Radioisotopes are used in radiotherapy for the cure of cancer and other diseases. Physics in relation to mathematics. Physics is a quantitative science. It is most closely related to mathematics as a tool for its development. Physics in relation to astronomy. Astronomical telescopes are used to study the motion of planets. Radio telescopes have enabled the astronomers to observe distant points of the universe. Physics in relation to geology. Radioactivity is used to estimate the age of rocks, fossils, and the age of the earth. Physics in relation to oceanography. Oceanographer seeks to understand the physical and chemical process of the oceans. They measure parameters such as temperature, salinity, current speed, gas fluxes, chemical components. Physics in relation to psychology. All psychological interactions can be derived from a physical process. The movements of neurotransmitters are governed by the physical properties of diffusion and molecular motion. Definition of physical quantity. Quantities that can be measured and in terms of which laws of physics are described are called physical quantities. For example, length, mass, time, force, energy, etc. Types of physical quantities. Physical quantities are classified into two types. One is fundamental quantities, another one is derived quantities. What is fundamental quantity? Fundamental or base quantities are quantities which cannot be expressed in terms of any other physical quantity. What is derived quantity? Quantities that can be expressed in terms of fundamental quantities are called derived quantities. Example for fundamental quantities are length, mass, time, electric current, temperature, luminous intensity. And then example for derived quantities are area, volume, velocity, etc. Definition of unit and its types. An arbitrary chosen standard of measurement of an quantity which is accepted internationally is called unit of quantity. The process of measurement is basically a process of comparison. To measure a quantity, we always compare it with some reference standard. For example, when we state that a rope is 10 meters long, it is to say that it is 10 times as long as an object whose length is defined as 1 meter. Such a standard is known as unit of the quantity. Here 1 meter is the unit of the quantity length. An arbitrarily chosen standard of measurement of the quantity which is accepted internationally is called unit of the quantity. The unit in which the fundamental quantities are measured are called fundamental or base units, and the unit of measurement of all other physical quantities which can be obtained by a suitable multiplication or division of powers of fundamental units are called derived units. Different types of measurement systems. A complete set of units which is used to measure all kind of fundamental and derived quantities is called a system of units. The FPS system, the CGS system, and then MKS system. So now we are going to see about FPS system. The FPS system is the British engineering system for units which uses foot, pound and second as the three basic units for measuring length, mass and time respectively. The CGS system is the Gaussian system which uses centimeter, gram and second as the three basic units for measuring length, mass and time respectively. The MKS system is based on the meter, kilogram and second as the three basic units for measuring length, mass and time respectively. SI unit system. This system makes use of only one unit of one physical quantity, which means a rational system of units. In this system, all the derived units can be easily obtained from basic and supplementary units, which means it is a coherent system of units. It is a metric system, which means that multiplies and submultiplies can be expressed as powers of 10. The International System of Unit SI. The 11th Conference General de Poets et Messos 1960 adopted the name Systeme International, the International System of Unit SI, for the recommended practical system of units of measurement. The 11th CGPM laid down rules for the base units, the derived units, prefixes, and other matters. Then SI is not static but evolves to match the world's increasingly demanding requirements for measurement. This system makes the use of only one unit for one physical quantity, which means rational system of units. In this system, all the derived units can be easily obtained from basic and supplementary units, which means it is coherent system of units. It is a metric system, which means that multiplies and submultiplies can be expressed as a power of 10. Base quantity length, unit meter, symbol m. Definition for length is 1 meter is the length of the path traveled by light in vacuum in 1 divided by 2,99,792,458 of a second. It was discovered in 1983. Base quantity is mass, unit kilogram, symbol kilogram, kg. Definition for mass. 1 kilogram is the mass of the prototype cylinder of platinum iridium alloy, whose height is equal to its diameter, preserved at the International Bureau of Weight and Measurement at Sèvres near Paris, France in 1901. Then base quantity is time, unit second, symbol s. The definition for time is 1 second is the duration of 9,192,631,770 periods of radiation corresponding to the transition between the two hyperfine levels of the ground state of cesium-133 atom 1967. Then base quantity is electric current and its unit is ampere and symbol is A. The definition for electric current is 1 ampere is the constant current which, when maintained in each of the two straight parallel conductors of infinite length and negligible cross section held 1 meter apart in vacuum, shall produce a force per unit length of 2 × 10⁻⁻7 Newton per meter between them in 1948. And base quantity is temperature, unit Kelvin, symbol K. The definition for temperature is 1 Kelvin is the fraction of 1 divided by 273.16 of the thermodynamic temperature of the triple point of the water. So 1967. Base quantity, amount of substance, unit mole, symbol MOL. Definition: 1 mole is the amount of substance which contain as many elementary entities as there are atoms in 0.012 kg of pure carbon-12. 1971. Base quantity, luminous intensity, unit candela, symbol CD. Definition for luminous intensity: 1 candela is the luminous intensity in a given direction of a source that emits monochromatic radiation of frequency 5.4 × 10⁻14 Hz and that has a radiant intensity of 1 divided by 683 watt per radian in that direction. 1979.